Hi, this is the Dopavision team, and my name is Hamid Mamani, the founder and original inventor of Dopavision technology. We are building a digital solution for myopia. This might sound a little bit science fiction, although this is heavily science-based and no fiction. In the next minute, we will tell you about the problem, about the solution, and the progress at the team.
Hi, I'm Stefan. I'm the commercial co-founder of Dopavision. Now, myopia is one of the most common visual conditions worldwide. Myopia or short-sightedness means that you see fine at close range, but you see blurry in the distance. It occurs when the eyeball grows too long, so the image falls a bit in front of the retina and not directly focused on the retina as it should. Myopia starts at younger ages, in let's say primary school children, and often is progressive until adulthood is reached, meaning it gets worse and worse over time. Now, the problem with myopia is that it has grown to incredible levels, especially in Asia. In urban Southeast Asian areas like Singapore, Hong Kong, or Korea, the prevalence of myopia among young people under 20 years of age is 80 to 90%. So soon there, everybody will be myopic. And the real medical problem with myopia is that high myopia, which is typically defined as 6 diopters or worse, dramatically increases the risk for very serious visual conditions later in life. Things like retinal detachment, myopic macular degeneration, or even cataract or glaucoma have a much higher risk of occurring in myopes, especially high myopes versus non-myopes. And these conditions can lead to loss of vision or even blindness. The exact reasons behind the growth of myopia prevalence are unknown. It's a mix of genetic and environmental factors. And a very recent development is that it's suspected to be connected with high smartphone use, especially at younger ages, which is suspected to disturb the day-night rhythm, the circadian rhythm, which is very important for the correct vision development.
Dopavision is developing a digital solution against myopia. There is a large body of evidence in the scientific literature that dopamine as a neurotransmitter has a central role in regulating the eyeball size. We have developed a technology that enables us to stimulate specific cells in the retina by light that can in turn modulate dopamine levels. Now our goal is to develop this technology into a software as a medical device that can be clinically validated and be used in children and adolescents in order to slow down or halt the myopia progression. Importantly, the light stimulation is in the visible range. This means that every smartphone screen nowadays can deliver the light that we need for such a stimulation in terms of intensity, wavelength, or duration. This makes us believe that this is a true digital solution because it doesn't need any additional hardware component except for a smartphone itself, which is available in everyone's pocket these days. Interestingly, the stimulation is also invisible because we target those cells of the retina which are part of the non-image forming visual system. This makes it also very easy for us to integrate this treatment into everyday life scenarios like gaming, watching movies, or educational purposes.
Hi, I'm Yesh. I'm the product lead at Dopavision. Now, I'm going to demonstrate to you how we administer treatment using our experimental device. The app runs in a smartphone which is placed inside the virtual reality housing. The housing ensures that the visual field is separated and the treatment is invisible to the eye, and no image-forming cells are targeted. The user wears the virtual reality goggle and calibrates the light until it falls inside the blind spot. This makes the light invisible, and the user then receives the treatment. In our experimental test, we used the treatment duration of 1 minute. To be medically effective, we estimate that the treatment would need to be taken for around 2 times a day for over a course of few minutes, which is actually a very tiny fraction of your everyday smartphone use, which is around 3 hours. Another possibility in the future is to integrate an eye tracker. This ensures that the user can do anything while they receive the treatment. The treatment duration runs over the course of your myopia progression. which is very typical for every myopia control out there.
My name is Tim Schilling and I am vision scientist at Dopavision. In my first year at Dopavision, we confirmed in proof of concept experiments that our technology is able to improve visual performance in humans. This is the first indicator that dopamine is increased in the retina with our technology. We could present these results at several recognized scientific conferences such as ARVO, which is a leading conference in our field, and IMC, which is an international myopia conference. At the moment, we are conducting further experiments in humans. First, to better understand the mechanism and to get indications for our dosage so that we can get our product better and we can optimize it actually. Furthermore, we plan to conduct animal experiments and therefore we are among the world's first digital health technologies to be validated in animal models. After this preclinical studies, we are planning to start clinical evaluations. With all these experiments, we want to show that our digital therapy is real medicine, and we have the clear goal to develop a medically validated treatment.
We are supported by the German government with a research grant of 1.5 million, and earlier this year we raised a seed financing round of more than 1 million led by Boehringer Ingelheim, one of the largest pharmaceutical companies globally. Our technology for retinal nerve cell stimulation is protected by an international patent. We plan to move into clinical studies next year and estimate to launch a first product into the market within the next 2 years. We believe at Dopavision we are taking digital treatments to the next level, where we develop a treatment that is as easy to take as a pill and has a direct physiological interaction with the body. We're always eager to engage with partners who can support us on our mission to develop a myopia treatment that can be seamlessly and effortlessly integrated into the lives of millions of people.